Great. Recording is on. Thank you again for joining us. We'll start now the. Oh, what is it? Okay. Sorry, just need to set up things. Excellent. Okay. All right. Webinar started. Thank you for joining us today. We have 3 great speakers today, and let me give you a little brief background on presenting the webinar itself. This is the 10th webinar since we started back the beginning of April. This was meant to provide an opportunity to a lot of companies in the small satellite sector, not necessarily members of ACCESS.SPACE, but in general companies in the sector around the world to give a presentation on their company or their project so that we keep ourselves busy during the lockdown. I'm sure everybody is busy, irrespectively, even though we are working from home. So we'll be recording the webinar. Presentation will be provided to you after the webinar. Welcome. I hope everybody's safe. How do we proceed? We will have about 15 to 20 minutes for each of the panelists, with about 5 minutes Q&A after that. And then after the 3 panelists will finish their presentation, we will have a wrap-up session with additional questions. So use the bottom of your screen. There is a small panel where you can write your question. I prefer that you please write your question there. I might ask you to read the questions if we have time. So be prepared to put on your microphone and ask for the question yourself. If not, I will do it from this side. Everybody's muted for a particular reason. That way we don't interrupt the speakers. And also we have so many people on the panel here that if we allow everybody to speak, it's going to be a mess. So I would like to thank Exotrail and Integrasys for sponsoring this webinar today. Thank you so much for you to give us your sponsorship. In fact, these webinars are free of charge, and in fact, on a voluntary basis by myself and yourself as well. The 3 panelists we have today: Alvaro Sanchez, CEO of Integrasys. He will be speaking about the software solutions his company have for monitoring radio frequency channels from of satellites. Then we have Chuck Lauer from SpaceBit. He will talk a lot about robotics on the moon. And David Henri, CEO of Exotrail, will talk about their products in electric propulsion systems. So this is the 10th webinar. We had a few in the past. If you're interested to find a little bit more about what happened in the past, but as well as we're going to have next week's will be an insurance panel, and the week after Space in Africa panel. I'm also preparing 2 additional panels, likely before we stop for the holiday season. Hopefully everybody will go on holiday in July. So far, we had a great attendance. Today, about 125 participants are attending, registered, and hopefully attending the webinar. From about 34 different countries around the world. You can see from the chart the countries that are participating in the webinar today. I will provide you the slides after the webinar, so you'll see this in more details later. We also have different types of attendees, from senior management teams to senior engineers, economists, writers, and of course international organizations like the ITU, European Union, for example, European Commission as well, space agencies as well, and then the type of different companies that are attending. You can see from here, from the right side, from satellite manufacturing, manufacturer of equipment, CubeSats, launch service providers, insurance companies, and so on and so on. Also, I'm advertising the possibility here for companies that have opportunities in their company to host new staff or hire new staff or host internships. Please let me know. I have CVs of several people that are looking for opportunities. So you can always contact me if you have the opportunities in your company for such things. I will not go over again. I've been doing this for a long time now on ACCESS.SPACE, but nevertheless, here are the directors of the Alliance. This is who we are. I'll provide you with the slides afterwards. You can read about it. We are about 76 to 80 organizations now, members of the ACCESS.SPACE Alliance. Different companies so far. You can see this from their logos. And a breakup of companies between UK, about one third in Europe, about 20% over the United States, and about 10% in the rest of the world. We can now start with the actual webinar. We said that Alvaro was going to go first, and then Chuck, and then David after that. So 15-20 minutes each. Anybody that has a question, please write the question down on the Q&A window at the very bottom of the screen. We can start now with you, Alvaro.
Thank you. I believe that the attendance has been reporting that they didn't see any slide from you. I didn't want to interrupt.
Oh, okay. Sorry about that. I thought I was actually sharing my screen, but I was not. Then sorry about that. You will get my slides at the end of the webinar. I will actually email them to all of you. Okay. Go ahead, Alvaro, please.
Do you see my screen, Tony?
Yes, I can, and I'm now shutting off my screen and my microphone as well.
So should I stop sharing my camera, or should I continue?
You can continue because I can see you and I can see also your screen.
Okay.
Everybody's looking at it. David, if you can actually stop your video, we can start. Thank you.
So thank you, Tony, for inviting us. It is a pleasure to be here. We have been more than 30 years now in business. We have been doing satellite communications since 1990. We have now 4 offices in different countries and a global market that enable us to have a very successful customers all around the globe with our technologies that solve their problems. At the end of the day, we are an engineering company, and what we aim to do is solve problems. That's what we love, all the engineers. So what problems? So the problems that we do solve is communications, satellite specific, and in an easy way. So we try to make satellite easier for more customers to adopt. And in this regard, what we are trying to do is to do tools very easy to use for monitoring, for being link budgeting, for installation, maintenance of any satellite network. So with this, we have managed to win 4 awards in the last 4 years. And we partner with strategic partners to us that are the BSAT equipment manufacturers and hab manufacturers and other in the chain. So for us, it is being a win-win success story. So this is just a very quick video of our facility. Our facility headquarters is in Spain, and it is being quite nice, but with coronavirus has been challenging as well. So with this, I would like to focus on, it has been challenging because it was one of the countries that was more affected. So we have an office in Madrid and an office in Seville, and also an office in Washington, D.C. And these areas have been severely affected by coronavirus. So we are now, most of us, working from home. Some of the people are still going to the office because they want, but many of us are working from home, and we are trying to develop and make our system more accessible now with thanks to communications. We are doing a lot of remote support, a lot of remote installation, a lot of remote training, and remote delivery, as well as virtualizing most of our systems for not having that big logistic challenges, because now all the shipping is delayed, all the logistic challenges become huge. So we have managed to adopt to this new way of working, the working environment. So ControlSet has been our key carrier monitoring system since the 90s. So it is a very robust tool, but very innovative tool. So it is coming with the old perspective and way of doing, but also bringing the new way of doing things in the last years. So it is adapted to LEO, low Earth orbit, MEO as well, high throughput satellites. So it is, let's say, bringing what it was very robust product for many, many years, tested by many, many customers, to a new area and to a different price point for those constellations that are being launched today. So it is something that enable new constellations to enter into the market and provide service in a reliable manner. So also what it is very, very nice is that it detects all the service failures. And again, we try to automate, to simplify. So just the product itself does the service level agreement report all itself. So nobody needs to develop that. It doesn't require very highly skilled personnel, so it is enabling further automation. So it's a very, very intuitive interface as well. And we are able to monitor a limited number of terminals, a limited number of antennas, and the refreshment is very, very real time. So it is about 100 to 200 traces in 1 second. So you are able to monitor about 200 carriers in only 1 second, which is pretty cool, because as LEO satellites move, you need this speed in order to ensure this the transmission are on track and with good service level agreement as well. Also, we have the monitoring, the automated monitoring mode that you can monitor unlimited carriers and detect any possible alarm or interference that have been within your communication path. We can record, playback, etc. So it is something that normally is quite difficult to monitor a link in satellite with RF, and also it enables you to be capable of deploying faster. So we are now working with the traditional VSAT manufacturers, modems manufacturers, but also we are working with the flat panel antenna manufacturers, maritime antenna manufacturers, in order to automate the access in GEO, MEO, and LEO. So it is something that it reduces significantly the cost of the deployment and the maintenance, because it is monitoring from the NOC and providing the view to whether it's an installer, whether it's an automated antenna or a flat antenna. This is a very intuitive video, which is in some way funny, as basically it's an installer that is installing a link, but he's pointing to the wrong direction. This is easy in GEO and more easy in LEO too. So even auto-acquire antennas are difficult to point and they can confuse. So you can interfere. So here is the satellite and an interference is coming. I don't know if you hear the sound. So basically an interference is coming to Earth. So the space policemen come from the space station down to Earth in order to guide him how to commission a terminal and able to use these tools in order to simplify and deploy much faster and therefore be more cost effective as well as more reliable in satellite communications and interfere less to other users in that regard. This is the new evolution that is a Motion API that is no-touch commissioning. So basically what it does, it's a software that it's embedded into a little device or into the antenna control unit or modem. And what it is communicating with the antenna and guiding the automatic pointing. So, and the automated cross-pole nulling and the calibration of the buck. So it is all automated and communicating with a very small RESTful API commands with the antenna in order to be used in maritime networks, in aero networks, in trains, and in future cars. So it is the connected car world is something that we see a big benefit for satellite communications, as there is no GSM everywhere. So we have been developing this product and patent this product for these new markets that we are penetrating with GEO. And we plan to penetrate with other satellite constellations as well. SatMotion SNG is an evolution for satellite news gathering that basically enables you to not have booking bottlenecks. Let's put an example. Right now with coronavirus, we had many customers that they had significant booking bottlenecks at NOC, because the NOC personnel was working remotely, very difficult to support their customers, and this kind of tools enable them to support much faster and reliable in order to access fully automated without the need to call to the support of that particular satellite operator, and the broadcasts were autonomous to line up in the right frequency, right power, and start broadcasting the news without having to interact with anybody and secure for those satellite payloads. It is the interface for Google Glass that we used to have. Now we have in many phones. Additionally to that, we have one of the newest products that won a few awards the last 2 years that is called ALSAT, Always Up. It is a tricky name, but basically it's coming from a project that we did, and it was called a similar way, and we didn't want to change that. So it is very nice because it's an evolution, and we are fully integrated with a hub. We are fully integrated with the NMS, and it automates a check over all your network or selected remotes, whether it's, again, GEO, MEO, or LEO. We have this, the capability of maintaining, see how the remote is performing, trigger some tests in order to see if the buck is wet or the cables has any retransmission, or the LMV is off, or the yellow of the buck is off, or any kind of hardware failure remotely without the need to go. So this is a very simple interface. Here is a satellite footprints, 5,000 remotes over Mexico that we did a project with the NMS, and we are able to do any pick and pull over any remote when the time is right to schedule all the network to be checked. And as well, we provide some interface here in the right that I believe you cannot see very well, but with all the information, and provide Excel reports, PDF, and very, very intuitive reporting capabilities. This is a video, but I will go to the next product that is another big capability of the carrier monitoring system. That is, okay, I have an interference because I'm trying to watch the American football game or the soccer game, and suddenly Madrid Barcelona is very tight, 2-2, 5 minutes left, and there is an interference, and we are not able to see the game. So we have an example here with a video that we are trying to retransmit a TV in TV tennis match, and suddenly we detect that the signal has some degradation, and we can look at how we can improve that. We see that there is an interference underneath our carrier. This is our tennis report carrier, and we are seeing here an interference, and that's why the content is getting very degraded. So suddenly, the constellation that are displayed here, I'm not sure if you can see, yes, the constellation that are displayed here, it's a QPSK, are being very shaky. Normally are much more clear. Also, the modulation error ratio that it's in the lower part of the screen, let me move this up, it's also decreased. So we called the broadcaster and we solved the interference, and now the constellation and the mayor are much better. If you see, the constellations are much cleaner, and here there is no interference anymore. So how we did that? With Carrier ID, that is a standard that we support, and this way it's very, very easy to mitigate that interference. You can mitigate in different ways, but again, vector set with a lows also is simplifying for the customers to utilize the system. So it provides you automatically all the measurements, all the estimation of the symbol rate, the MER, the VER, ARP measurements, and it is very fast and reliable. With a very affordable solution, you can get transponders up to 1 megahertz, 100 megahertz, or more. We support up to 1 gig of bandwidth analysis, but it goes in steps of costs. Moving a little bit forward, we have a new tool. So here we found something that today a lot of satellites were going to be launched, especially LEO and MEO. And we found that not many people knows how to do a link budget in a GEO, and less people in a MEO or a LEO. So we found a path to market with a very simple and user-friendly interface in order to do link budgets with a traditional antenna or a flat panel antennas as well. So what we are doing is a very, very graphical link budgets and reports in order to have even salespeople to use this tool, or anybody who is not a satellite expert in that regard. So it's very accurate, and it maximizes the accuracy. We can provide and load coverage beam maps and provide very intuitive reports. It supports wide beam, high throughput satellites, and also GEO, LEO, and MEO. We can do full duplex scenarios, as well as a network where we select a region and drag with the mouse, and it calculates over a full country or over a full continent thousands of link budgets in just a few seconds. This is the interface, and this is the video that basically what it does, it is enabling to calculate link budgets. This is the report with power equivalent bandwidth, transponder usage, etc. So we select and load a scenario with a satellite footprint. So we choose the TX and RX transmission, and we can select the region to calculate a regional link budget as well. So in this link budget, we can look at the forward and return. And here we see the best and the worst locations in order to get that particular link budget. We can upload any satellite footprint from GXT files, which is normally FCC or ITU standards. And we are able to see in just one view what is critical. But then for all the link budget experts, there are many calculations, about more than 1,000 calculations for only 1 point, or 1 million calculations down there in order to analyze any possibility of this link budget. Also, we are supporting today LEO and MEO satellite footprints. So here we have a LEO constellation that we are able to calculate a link budget over a particular LEO, over a time, over 24 hours, all the satellites that are passing through over a region. So it's a very, very intuitive way of knowing how much signal will I have in which particular location with this particular orbits, with this particular satellites. So this way enable us to know how many we need to launch in order to have a 20 coverage, and can help us to determine how much link will I have when I have service for that particular customer. So it's a very, very unique tool.
Less than 1 minute.
Okay, just on time. As a conclusion, we are a great partner. We are very innovative, and we have very high return on investment of our products. We save OPEX, and we are very flexible. So we have a full team of people to do customization projects for the ones that need a little tailored to a particular product to fit completely their needs. And that's a conclusion. We have the best carrier monitoring systems and affordable prices. Thank you.
Excellent. Thank you so much, Alvaro. Now with the question and answer, I'll ask you one question, then we'll go with Chuck just in a minute. We're gonna ask the remaining questions later on the Q&A session. So from Sulal Mahmood, the question is the following: how is Integrasys different from Spectrum Analyzer or the iDirect and Comtech monitoring tools?
Sure. So basically, our tools are additional to those. We work with iDirect and Comtech, or Hughes, or UHP, and SpaceBridge in order to complement in RF. So these manufacturers are experts in IP traffic over satellite, and we are experts on RF over satellite. So what we do is to monitor all the RF chain, not the IP. So that's where it complements significantly, because you can see problems in IP that you don't know why it's happening. And with these tools of RF, you are able to analyze and solve the problems that happen always much faster than any other way. So yeah, and they are easy to use. So you don't need to be an RF expert to understand those.
Excellent, excellent, excellent. You don't have to be an engineer to use your tools. Yes. So Alvaro, I'll ask the remaining questions later. We're now gonna go to get Chuck. Chuck, please come on. Excellent. So you can start anytime you want. I'm gonna go off the video right now. And for the attendees, I'm gonna ask the questions you asked to Alvaro later. In the meantime, you can continue asking questions to the next panelist. Thank you.
Okay, my slides up?
Yeah, they're good.
Okay, thank you everybody, and thank you Tony for putting this whole series together. Maybe there's going to be a publication of the series at some point once the whole thing is over. I'm the Chief Business Development Officer for SpaceBit. I joined SpaceBit last September, right when we did our first rollout of the Lunar Surface Project at the New Scientist Live event at the big expo center in East London. So I've been working on this project for about 9 months now. SpaceBit, even though you can tell from my accent that I'm not a UK, SpaceBit is a UK company. Our headquarters are in Canary Wharf. We're looking at setting up a technical center somewhere in the greater London area, possibly Harwell, Scott. Still TBD, but right now everything is working in the virtual mode, and as hardware comes together this fall, we're going to need to figure out a place to do this. Our focus is on micro robotics for space, specifically for lunar applications as our mission, although there are some interesting things that we're looking at too. Focuses on data and software, not the hardware, but we do need to be a hardware production company as well, and we're also looking at distributed ledger technology for space applications in general. Our challenges are the same as every other new space company in terms of capital, insurance, markets, technologies, know-how. Dealing with the commercial lunar business proposition, we have an extra challenge that it's not obvious what the real commercial markets are, therefore presenting a return on investment for a venture-backed business on something doing commercial activities on the moon provides an extra challenge to the normal new space set of challenges. But we're doing this because we feel there is a drive to push humanity forward, and the next place is the moon. Our founder is a guy named Pavlo Tanasiuk. He is a serial entrepreneur, started a fintech and sold it to a larger company. He walked away with quite a few million and decided that he wanted to follow his dream and do a space project. So he started SpaceBit, and then when all of the focus on the return to the lunar surface came up, we decided to make our first mission, the lunar robotics, and develop the first UK mission to the moon as a SpaceBit brand identity. So this is micro robotics. The micro part is a technical challenge, but it's also a financial necessity when the cost of getting to the lunar surface is over $1 million a kilogram. So anything you do is 20 times as expensive as the equivalent weight in gold. So when you start with that as your fundamental premise, doing things that are small and light and fast are kind of a fundamental requirement. So some elements of it are much lower risk because the price is relatively lower. It's still crazy expensive, but you know, we're not talking about hundreds of millions of dollars for a mission or the original Google Lunar X Prize value proposition that you spend $100 million to raise a $20 million prize. But what we're doing now is relatively low cost and modular and repeatable. Our first rover is called Gumo. It's a Japanese name. It means morning spider. Since our robot kind of looks like a spider, one of our colleagues in Japan found a Japanese saying that if you see a morning spider, it brings good luck. So we picked that as our name. The body itself is a standard 1U CubeSat in order to be able to access a lot of the standard CubeSat components and systems, solar panels, power supplies, onboard computer systems, all of that. It's easier to develop that if you have a standard form chassis. The legs are the custom engineering. There's no this that exists. And so that's where a lot of our engineering focus is now. Another reason for doing these things small is that at a light weight, you can design a system to operate in swarms and get more data by spreading a series of small robots over a wider surface. We believe that the the system. This is not actually to scale. If I shrunk down Gumo to the appropriate size, it would be just tiny. You wouldn't even see it on the screen. But it just gives you some idea of we're an order of magnitude smaller than conventional rover designs. The reason for the legs is quite simple. Our intention is to go into very challenging terrain, and we believe that the leg system is more appropriate for tough environments than a wheeled system is. In particular, our focus is going down into lunar caves, and in that case, our theory is that legs are a better choice. The reason for the swarm technology and the cave mapping is that we think that in a future commercial lunar economy where there's significant human habitation, having subsurface habitable environments could be a better choice than building the big regolith igloos on the surface that people are hypothesizing about human occupation on the moon. And in order to know whether that is a viable proposition, you've actually got to go down there and explore. And the only way to do that is with a swarm type system that you can send robots into the cave and relay the data back, because the RF isn't going to get to the lunar surface. The wheeled robot that's up on the top is our mothership. That one's called Kitsune, means fox in Japanese. And so the wheeled rover carries 2, 4, 6, we're still working through the final details, but we will carry a number of the small walking robots, because the wheeled rover on the surface has more range, more power, more ability to survive the lunar night, and can also relay back from the exploration robots to the mothership and then to the lander. The comm architecture on the moon is a big challenge as well, and the way that we work is by relaying our data back through the lander, which then gets relayed back to Earth as part of the service that we're dealing with. So we have the small walking robots as our first mission. Our second mission would include the wheeled mothership, and we would be going to different places on the moon, depending on who's flying. The general value proposition for SpaceBit is that our focus is on the surface technology, not the landers. We do have some long-range plans to develop our own lander technology, but what enables all of this is the NASA CLIPS program. It is one of the most commercial-friendly programs I believe NASA has ever put together. They book 80% of payload. They leave the other 20% for the commercial companies. And so we have booked our first flight with Astrobotic, flying on their Peregrine lander, which is on the left. We're in discussions now with Intuitive Machines about booking theirs. Both of those are 2021 flights. Astrobotic is flying on the ULA Vulcan. Intuitive Machines is booked with SpaceX. Maston is the newest award. They're flying in December of 2022 to the Lunar South Pole region. And there'll be another CLIPS award that hasn't been announced yet, which is also South Pole for the NASA Viper rover. That'll be a very large lander, a 500 kilo class plus, because the NASA rover is quite large. And there'll probably be some extra commercial payload on that. And then Blue Origin is looking at a 2023 cargo demo of their lander, which is a 3.5 ton monster lander that is part of the NASA human landing system contract, but they have a cargo version as well, which has the little cranes on the top for bringing things down. So our general philosophy is book every ride we can, get to the surface anytime we can, and develop expertise in the lunar surface robotics with cooperation with other lander companies. So in our tech demo system, our focus has been on the legs, going from an oversized first development unit through a couple of engineering test units using the one UCubeSat body. And the system on the right is a working programming development unit, because figuring out how to walk with 4 legs is simple for mammals, and not so easy for robots, where you can only really move 1 leg at a time and keep the other 3 on the ground for natural stability. So we are looking at several different leg designs and several different actuator types, going through trials on this now. The unit on the left is using a very small stepper motor built by a company in Japan called Microtech Labs, and that's a very tiny 13mm diameter encoder control built-in DC brushless stepper motor. The one on the right is using a linear servo motor, and because we're spending $1 million a kilogram to get something to the lunar surface, the hardware cost is background noise compared to what we're actually spending to get there. So we want to try several different systems, put complete integrated systems into thermal vacuum chamber tests, and effectively do a dance-off between 2 different leg systems and determine which one it is we're going to fly. At this point, we don't know. Motors this size in the lunar environment have never been done before, and there are significant technical challenges, both relating to the heat and relating to the dust in the lunar environment, that these motors are going to be very challenged to be able to work through. We do not expect to survive the lunar night. A robot this size is on a week-long death mission, and it will die when the sun sets, and will then just be an artifact on the lunar surface for the indefinite future. This is our engineering development unit that we're doing the programming on right now. There are a total of 12 servo motors, 3 on each leg, and designing the programming to be able to control the robot, deal with the tough environment, and adapt to terrain. Oh, I should turn that off. This is our Predator attack drone version of the robot. They'll jump up and bite your head off. Of course, not really. That's looking at the thermal issues associated with this. All of those hotspots mean heavy power, and power is also a limited factor when you're dealing with a 1U CubeSat form factor. So having low power and low thermal load motors is another thing that we're looking at. We do have a significant collaboration going in Japan. We signed sort of the equivalent of a Space Act agreement with JAXA ACCESS, and Dr. Hariyama is our principal science advisor for lunar surface science. He's actually the discoverer of lunar lava tubes from the Japanese Kaguya lunar mapping mission. The picture behind me is actually from the NHK collaboration with JAXA on the Kaguya mission some years ago. And we have a very skilled lunar surface scientist advising us. We actually went down into a lava tube. This is Pablo, our CEO, in a lava tube cave at the base of Mount Fuji. And actually having gone down into one, it confirmed our initial theory that this is a very challenging environment, and an adaptable, robust leg system is going to be easier to navigate in this environment than any kind of a wheel type system. So our focus is on the surface of the moon. Others are doing the delivery to the moon thing, starting in 2018, 2019, when NASA developed the CLIPS program. So we're focusing our first spending on step 3, but ultimately, if we create a cislunar economy where there are humans, there are commercial activities going on the moon, that what we're doing is part of that commercial ecosystem. And there's a lot of people doing this in other robotics companies, the Eclipse lander companies. A Japanese company called iSpace has raised $100 million in venture capital funding for their own lander and rover program. They were one of the Google Lunar X Prize companies. And the most interesting thing in terms of people, I mean, in Artemis, we know that's a normal government type program, but the Dear Moon project is a charter flight to fly around the moon by a Japanese billionaire named Maezawa-san, and he will fly with SpaceX on their new Starship in the 2023-2024 timeframe if SpaceX gets that bird flying, and he will take 8 people with him on a trip around the moon. So this is $1 billion of consumer discretionary spending related to getting people back to the moon as well. So our mission pace is, every 18 months notionally to get to the lunar surface on every ride we can, with progressively more ambitious robotic programs, and get to a place where there's one of the skylight openings to a lunar cave, and get down in the cave and map it using HD photography and 3D LiDAR scanning to create a full terrain map of the interior of a lava cave.
1 minute, Chuck.
Okay, I'm good. Our initial missions monetization is really based on sponsorship value. We've had 35 million impressions so far since the rollout. You look at some of the other big space events like the SpaceX launch or the first all-female spacewalk, you can generate 1 billion views on something that's interesting. So we think that we have a good value proposition for sponsorships, and we're looking at trying to find strategic partnerships that are interested. Ultimately, our business model is based on commercial data sales and supporting the lunar resource development by providing prospecting, essentially, assay-grade ground truth that would allow a lunar resource company to actually confirm the resources and have the data that they need to close their business case, and our core mission of subsurface mapping for scouting of human habitation sites. So that's it for me. I will stop my share. And
thank you for that, Chuck. Now we have the questions. You can see them on the screen and below you as well. Let me read you out a question, an anonymous question. So how do you test Gumo for a reduced gravity environment?
Oh, very good question. A lot of it we can do with partial gravity offloading, either with an appropriately sized helium balloon or one of these sort of crane things that take off 5/6 of the gravity. One of the lunar test chambers that we're dealing with actually has that rig already built into it. There's one in Japan and one in Korea that have this capability. The other way is to do a lunar surface parabolic gravity flight, a reduced gravity parabolic flight with a small plastic enclosed test chamber and regolith on the bottom. So we've got a couple different ways to do it, and we do actually have to try that because traction is a key issue. If we move the legs and nothing happens and we can't get around, it'll be very embarrassing. So that's one of our key tests.
Excellent. Let's move on to David, and then other questions will be asked to you just after we finish and on the Q&A session later. Okay. Thank you, Chuck. Chuck, can you just, I'll stop the video, it's fine. David, you can start anytime.
Thank you, Tony. So I'm gonna just share my screen. Let me know if you can see it. It should be okay.
Yeah, it's okay.
Perfect. All right. So hello, everyone. Thanks a lot, Tony, for the invitation to that webinar. So I'm David Henri. I'm co-founder and CEO of Exotrail. We are a company developing agility solutions for the space markets with a focus on transport solutions for small satellites. We are a bit more than 25 people now, 26 exactly. We are based in France. We are developing today propulsion systems and mission design and operation software. All the electric propulsion system development happens in Paris suburb, and all the mission software happens in Toulouse, in the southwest of France. I'm sure that you know this space city. And we are we are a startup in the sense that we have been created only actually 3 years ago, and since our incorporation, we've raised a bit more than 6 million euros from venture capital in Europe. We are working with many partners, so you'll see here our investors, but also we are working with CNES, ESA on some contracts, CNRS, and some companies, European Commission as well. And we've let's say, successfully also won some awards with some fundings related to these awards, close to 3 million euros. So we're mostly in product development mode until the end of last year, and this year is our first year of, let's say, revenues, and we already have signed contracts with customers in France, Europe, Asia, and actively discussing with customers a bit everywhere on the planet, including the US and also just in Europe. And as I said, so we are focused on bringing agility to space in the sense that we want to be able to allow small satellites to move on orbit. And what we do right now is that we are doing this with two family of solution: propulsion systems, mission design, and operation software. We have a long-term vision that I will explain a bit in the following slides, which is to allow basically to be a transportation provider for constellation of small satellites, and eventually becoming an operator for on-orbit servicing with a fleet of vehicles equipped with propulsion. So we have really three sub-missions, let's say. Our core objectives are really to lower deployment costs of constellations. So we want to help our customers to efficiently deploy their constellations in orbit. Because we feel that right now in the market, small satellite operators, they have a choice in between being launched for a relatively low cost with larger rockets, like Falcon 9, for instance, or being launched precisely on orbit with more dedicated launches and smaller launches. What we want to do is eventually effectively lowering the deployment costs by allowing our customers to fly on larger rockets for a cheap cost, and then use transport solutions to go where they need to operate. And this with propulsion, but also with other technologies in the future. And doing this, we allow our customers to gain the benefits of both worlds. So they would be able to gain both low launch costs, but also precise operation on orbit. The second core mission is to allow our customers to gain the most out of their constellations. By allowing them to operate exactly where they need to be, they can have the good resolution they need for the market, the good link budget, the good lifespan, because precisely we are granting them the ability to stay where they need to be. And finally, and that's probably the core mission, we want to reduce space pollution by allowing satellites from our customers to be able to avoid collisions, to deorbit safely at the end of the mission in order to effectively tackle the space debris problem. So that's really the vision that we have, what we think the, let's say, constellation world should be. Where we think, what we think should happen is that customers should launch and people should launch satellites with larger rockets on orbit, at least the bulk of the constellation, in order to guarantee a lower cost, a lower launch costs, and then use propulsion, whether it's on board the satellite or not, to be able to go in the final orbits and operate there. Once you're in the final orbit, if you are equipped with onboard propulsion, you can change this orbit, and changing this orbit means optimal performances, because you can, let's say, change the performances of your constellations, follow the market in the end. You can also avoid collisions. And at the end of your mission, you can safely go back in the atmosphere to safely re-enter and prevent any space debris to happen. And the way we see this at Exotrail is really in three phases. What we are doing right now is that we are helping our customers with two family of solutions. Hardware, so this being our electric propulsion systems family of products. We call it EXO-MG. And I will deal a bit further into this, but it's onboard propulsion. So you put a propulsion system inside a small satellite in between 10 and a few hundred kilograms. And thanks to this, it can move on orbit. We also provide a set of, let's say, subsystems for propulsion, mostly fluidic subsystems, which can be adapted for larger satellites as well. And we also develop a family of solutions with regard to mission design and operation. And this is called the EXO-Ops family of products. And the EXO-Ops family of products, let's say, carries our customers from the early phases of propulsion, meaning how it impacts the business case, how it impacts the satellites, through operation of the propulsion system, global flight dynamics solution, automated collision avoidance, and so on. That's the first phase. The second phase is to become, as I said, a transportation solution provider with our software and our propulsion systems, but also a vehicle that will embark propulsion system, a third-party vehicle that we think for nano satellites, so for very, very small satellites, is more efficient than onboard propulsion. And then our long-term vision goes beyond this, where we want to transform this vehicle into an on-orbit servicing vehicle that will be able to, as I say, contact satellites. And if you can contact satellites, then you can deorbit them, you can prolong their lifespan, you can eventually repair, assemble them, and so on. So right now, as I said, we are focusing on propulsion. For us, we really consider that it's a must-have for everything that we've said before that. With propulsion on a constellation of small satellites or a unique small satellite, you can deploy your constellation, you can optimize the performances, phase your orbits, maintain your orbits, avoid collisions, and dispose of your satellites at the end of the mission. All the constellation, most of the constellation projects, if not all that we see now rising on the market, all baseline propulsion, because now the technology starts to be available. And we also believe that this might not be an option anymore in the future, following regulations on space debris, both in Europe and in the US. But, and there is a but, this comes with some hurdles that a propulsion provider needs to tackle. A propulsion system, we think that electric propulsion systems is the good solution for small satellites because volume and mass is really constrained and you need the efficiency of electric propulsion. But electric propulsion always has one drawback, which is that maneuvering takes time. Then it's a fairly complex system. It has an impact on attitude control, power, and so on, which most of the time small satellite integrators cannot really tackle. And it's a bit complex to operate. It has, as I said again, on the ConOps of our customers, a high impact. And what we believe is that to tackle this, we effectively need combined solutions, high thrust electric propulsion system in order to gain from this high thrust short maneuver, standardize a lot of things in order to make the integration easy, and also develop this family of software in order to make propulsion easy to operate for our customers. And that's really what we are doing. We are not a propulsion system provider. We are a propulsion solution provider. We help our customers through all the phases that are linked with transport in orbit, whether it's with our propulsion system or not. And doing this, we can optimize both the system and the mission aspects of the mission due to this unique approach that we have. So a bit more in detail, our propulsion systems have unique advantages. We are not alone to do propulsion in the world. Where we are really unique, this approach with the software that we have is that we are extremely flexible and extremely scalable. We baseline our product on modules, electronic modules, fluidic modules, the thruster. We develop 2 thrusters, and by playing with various tank sizes and these 2 thrusters, and effectively putting several of these propulsion systems together, we are able to target satellites from very small CubeSat, 6-unit CubeSat, to larger small sat platform that can weigh 200, 300 kilograms. And the hardware behind that is effectively the same, thanks to this flexible approach. And then the second advantage, as I said, is really thrust, as I will explain a bit later. We are using the Hall effect technology, which is used on large satellites, and it grants the highest thrust that you can get out of electric propulsion in order to get short maneuvers. So that's really the idea. You have several technologies being developed for small satellites. They all have different performances points in terms of efficiency, fuel efficiency, and thrust to power ratio eventually. And our technology is by far, so 3 to 6 times higher than the closest competition. We have the highest thrust to power ratio. And the idea is that for a given maneuver, so for instance, if you have a 20 satellites constellation, you want to do a given orbit raising, RAN phasing maneuver, we will transform the duration required for this maneuver from 12 months to 3 months. It depends obviously on a lot of different missions that you can do, but we will gain months of operations of satellites that can generate millions of revenues per year. So it does come with a drawback, which is that in some cases we are a bit heavier than the mission, but we feel that gaining 6 months of revenues for a satellite that generates 10 million euros over 5 years is better than paying for an additional 1 or 2 kilogram at 5 or 10K the kilogram. So that's really the idea, flexible products, high thrust for quick maneuvers. So we've only been created in 2017, and actually until November 2018, we were only 5 in the team. We were 18 in December 2018. And only 1 year after that, actually a bit less than that, we managed to build our first demonstrator, which eventually embarked all the first version of our modules. It was supposed to be launched at the end of last year. It was on a PSLV, got delayed a few times, and then got caught a bit in the COVID situation. Now it's planned for later in the year, and we have many other launch planned now. We've signed contracts with many people now, with CNES, ESA, but we've also signed contract with ClydeSpace, European, let's say, macrosatellite leader, for the Eutelsat constellation. And we have other missions down the line, both demonstration and also we are discussing with many customers all around the world for multiple missions. We've really got a agile hardware development. It means that every year, every 12 to 18 months, we want to fly on orbit with demonstrators in order to get heritage as soon as possible, try something. We're not afraid to risk things. We're not afraid that everything will not work because we know that it will improve our products as quickly as possible. And we are really using this agile hardware development that in other part of the space industry got some very good successes. ExoOps, as I said, so there are a lot of information on these slides, but ExoOps is a kind of unique end-to-end tool for mission design, optimization, and operation. It's not only linked with propulsion, it does basically everything you can do with propulsion. So from a comparison of propulsion systems with our analytical module, advanced propagation of the maneuvers, optimization of the maneuvers with a numerical module. But you can also have access to constellation analysis on for instance, the impact of ground station network. And also we can scan a lot of different launches available, adopt several satellite sizes, select different propulsion systems. And from all of this, we can get the optimal launch scenario based on KPI that the user can define. This is all cloud-based. It falls a bit to what Alvaro was saying at the beginning of the discussion, which is we really want to make also that software usable for non-experts. And that what we see is that flight dynamics software in the market can be very expensive, but also the engineer using this software can be extremely expensive. And what we want to do is have a unique tool that can be used by sales team, system design team, mission design team. So we've released this product a couple of months ago. We got announced one customer already, which was Eutelsat. And also very importantly, ExoOps has an operation engine, meaning that we can put all the flight dynamics side in the numerical module inside the ground control center of our customers. So it's effectively something that does the bridge in between the mission control center and the numerical module of ExoOps mission design in order to automate collision avoidance, automate maneuvering, acts potentially as the main flight dynamics engine of the constellation or of the satellite. And finally, so we are, I always like to let's say, finish this presentation by, for me, what is the most important, which is our team. So as I said, we are now 26 people at Exotrail, effectively actually 27 soon. And we are mixing experience and innovation. So we have a lot of people that, let's say, come from non-space related industry or that just came out of studies, let's say. But we have a lot of experience from space players. So we feel that we need to combine both to make things work, both efficiently, but also with a high level of quality and reliability. And so this is how we moved forward in the past few years. to be able to help our customers essentially be agile in space and to operate as efficiently as possible their constellation. So that's it for me. I hope it was quite clear, and then let me know if you have any question.
Yeah, we have questions for you, David. Don't go away. Caleb, Henri, would you like to ask a question? I'm going to allow you to talk now.
Sure. Can you hear me?
Yes.
I wanted to ask about the satellite servicer that was mentioned briefly earlier in the presentation. It sounds like a long-term goal, but I was curious your timeline for that, target market as far as orbit, satellite, things of that nature.
So your question is on the roadmap, or just on the additional details on that?
I guess both, but I guess really, when would you hope to get into satellite servicing? You're already in propulsion and software. You have that for mission management, things like that. When does in-orbit servicing come into the picture? Yeah.
So our objective right now is to have a first mission for the let's say, we based this on a vehicle that we call the spaceman. And there is two, let's say, version of the services. The first one is the transport version. So we are able to transport nanosatellites on orbit after the launch. And then in the second version, we are able to reuse this vehicle. So potentially to do the same thing, but reusable, and also do on-orbit servicing with contact. And on this, the time scale is the following. We want to have a first launch on the transport side in 2024, and on the servicing side in 2025.
Your screen.
So we know that there are other people on. Sorry.
So you just froze. Go ahead.
I froze. That's sad. Connection. So yeah, we hope to have a first, let's say, version of this transporter in 2024. To answer your question, so to start the services, the first services in 3 years from now, 4 years from now.
All right. Can I get all the panelists together on the video, please? We can start the Q&A session for all of you. I have Sulal that wants to speak, so I'm going to let him the microphone on. Just a second. I'll find you on the list. Sulal, can you present yourself, who you're from, and what you do, and then you can ask the question, please.
Hello, can you hear me?
Yes, go ahead.
Hello, all the panelists, and especially Alvaro Sanchez. I'm Sulal Mahmood. I'm from Pakistan. I'm NOC engineer. I'm serving as a NOC engineer in Pakistan Telecommunication Limited. So my question is with Alvaro. I have followed him for a long time. I'm his best friend, as you know me. So my question is for him that, yes, he said that a SATCOM industry is not expanding. Actually, I'm a NOC engineer. I have 2 years of experience with iDirect and Comtech and huge network systems. So I have monitored more than 1,000 carriers. So the spectrum analyzers, the iDirect monitoring tools like iSight, iBuilder, and iMonitor, you can monitor IP carriers as well as the RF system too. In my opinion, yes, most of the time. If you are an experienced technical person, you can check where is the fault, whether is it in RF section, whether it is in IP section. But which I see in your presentation is that your tool allow a non-technical guy to approach the SATCOM system. This is the difference between your monitoring tools and the Comtech or the iDirect monitoring tools. So you just said me that we are having problem with the SATCOM industry. How will you overcome these problems, and how will you see the future of Integris system after 10 years?
Sure. So basically, what we are doing is added value products, and what we are doing is to work with those companies you mentioned for making greater products more accessible to everybody. So what we are trying to do is satellite to be accessible by anybody. and be more popular. How our industry will grow, becoming mainstream. So today, satellite is not mainstream, it's the, let's say, the last resource. So how we all will benefit making that happen, because otherwise we will be a very niche, and as niche, there will be not a big market, and as big market, there will not be a big investment, and investors will withdraw their investments, as is happening now in the industry, as we are suffering by uncertainty. So we need to prove investors of satellite communications companies that it's worth it, and business cases can can succeed. So this is important for the industry in general to grow. So there was a question from Sulal in the comments that it was, what are the biggest challenge for Integrasys? So our biggest challenge for is that we are doing a very good path to growth. And in this path, we are finding that many of our partners are currently not growing. So what is our aim? To help them grow, and this way we can grow as well. So that's our path. So how do we see Integrasys in 10 years? With much more products than today. We are developing very fast new products and new technologies in order to solve new challenges, and being a global company. That's how I see, and how I would like to see.
Well, thank you very much. I got it. Thank you.
Thank you, Shukran. Tony, you're muted.
You're mute.
Okay, thank you for that. Sorry about that. So Chuck, I have two questions from the screen here from anonymous people. So I'm going to ask them together, actually. They're quite simple. The first one on the top says, how are you going to operate the space-based robots in terms of monitoring, commanding, and planning, for example? And I would add to that, you know, do you have to operate by bringing back data to Earth via some kind of communications link and so on? And then the other question is, how do rovers navigate on the lunar surface?
Yeah, it's a version of the same question. Our initial missions will be teleoperated. These are not autonomous systems. It would be it's challenging enough to do this at all. To try and do it autonomously is a bridge too far. So we will be literally looking out the video camera and also monitoring from the external cameras that are on the lander. We'll be in the visual range of the lander cameras too. So we'll actually be able to see where we are and what we're doing. And then we'll be looking out the video screen and navigating through a teleoperation, remotely piloted type environment. There are IMUs on the onboard computer, so we will have some relative positional data to where we are to the lander, or things like recovery of loss of signal and things like that. But it will be a teleoperated system for the first two missions before we can even think about doing anything with autonomy.
Okay, thank you. Some very, very interesting projects we have here today on the panel. So David, there are a couple of questions on the screen. I'm going to ask Renato to ask his. I think his question is most likely addressed to you. Renato, just be ready to take the microphone. Can you also present yourself to the audience? Just a second. I think you should be fine now, Renato.
Yes, I've unmuted. Many thanks, Tony. So I'd like to ask, are you seeing changes now with the design of the commercial satellites to be ready for things like refueling to extend life and also recovery rather than becoming items of junk? Or have we still got to wait for those standards to develop?
Thank you.
Thank you.
Yeah, thanks for your question. So what we are seeing right now in our first markets, let's say, which are more linked to small satellites, is effectively a will to avoid these satellites to generate debris, but not yet to being reused or recovered or repaired or recycled, or even let's say refueled for small satellites. Because economically it makes less sense right now as of today. However, what we see is for larger satellites, an increasing interest in being able to do so, not for satellites that are being built right now, but what you mentioned in your question is the key item for us, which is standardization. And the reason for that is that there is an order of magnitude, if not more, in the price difference to service what regardless of what you put behind servicing, whether it's deorbitation or repair or so on, in between a satellite that was meant to be serviced and one that was not meant to be serviced. So there is really two phases. One is on satellites that are larger satellites, I mean, being able to use some already existing features like adapter rings, for instance, as an already existing kind of pre-standard that you could use, particularly for deorbitation, to attach, to contact. And then in the second phase, to really conceive, let's say, build satellites that are meant to be serviced, but in an advanced manner. So through refueling, repair, and so on. I think the first phase is more or less ongoing. We've seen a first mission early this year to demonstrate, let's say, a contact and a life extension service in GEO. And I think that's very, very promising. There are a lot of companies that are doing this in the market in Japan, in Europe. And the second phase, which is building larger satellites meant to be serviced, I think is not yet ongoing. It's more in the kind of in the roadmap, I would say. Arriving, I would say, in about 5 years from now. That's what I feel.
Yeah, I think I'd add to that. There is a standards development group called CONFERS that was formed a few years ago. I think DARPA in the U.S. Defense Department was actually the lead on it. But there is a forum now for all of that standards development, and anybody that's interested in that sector should really be a part of it. It is an international group, and I think it's doing good work.
Yeah, that's correct. Actually, CONFERS also is quite involved with the small satellite ecosystem. Regularly every year in August in Logan, doing a committee or a session there, which I think is good because I think that the small satellite worlds can, let's say, develop solutions to set first large satellites, because that's where the money is. So I think connecting the two worlds, and that's what CONFERS is doing, I think is very good. Yeah.
Chuck, can you come closer to the microphone, because sometimes we can't hear you. So Alvaro, you want to say something?
Yes, to add a little bit, so right now many GEO satellites are coming to end of life, and there are not that many launches now. Actually, there are fewer and fewer every year. So there is a need of connectivity. So refueling is a must and must happen quite soon. Otherwise, it is a big challenge for our industry and for service providers like BT, that the cost of the bandwidth might not reduce anymore if there are not many satellites left.
Well, it means that the geostationary arc is going to be freed up, and we're going to have more and more non-GSO LEO MEO constellations. But David and Chuck, I mean, you could actually combine your products together, and then you can have a flying spider, morning spider on the moon, I suppose.
Yeah, well, one of the things I didn't mention is that the comm to the moon is extremely challenging. The bandwidth is very limited. We're having to put a HD signal through an analog dial-up level of connectivity, which is a big challenge in and of itself. And ultimately, as more things happen on the moon, a commercial lunar data relay satellite system is going to be needed. And those 12U type CubeSats that are behind David's head are the sort of a thing that would be appropriate for a lunar data relay system. And I'm hoping that there can be a group put together to work specifically on that to provide a commercial comm architecture in the lunar environment.
Well, come speak to me after the webinar. We'll discuss that. I have an idea. Anyway, I have some more questions for you. Let's see, Alvaro, Kamlesh. Let's see, Kamlesh, we have time for you to speak, if you're okay. A good friend of mine from Inmarsat. Let me find you on the participants list. Kamlesh, here you are. Kamlesh, you are up for speaking now. Go ahead, we can hear you. Kamlesh? Okay, maybe I'm gonna ask the question then, Kamlesh. Okay.
You can write it down and reply by the Q&A if you prefer.
Okay, well, the question is for you, Alvaro, from Kamlesh. Do your system use carrier ID, which is something just been talked about for many years so far, that may be transmitted to identify operators of the carrier? If not, how is the operator gonna be tracked?
So basically, carrier ID is a standard that embeds some information into the into the transmission of the modem or modulator. So what we do is to demodulate and decode this information so we can know the MAC address of that particular transmitter that cannot be changed. It's always stays this forever. And also we can decode if it is included the telephone number, the location, and more parameters within seconds. So whether it's from the main carrier, whether it is from the interference underneath. And as well as Renato's previous question, we can detect carrier in carrier, modulate both carriers and also the interference underneath. So whether it's carrier in carrier, we detect the carrier ID of the intruder as well. So whether it's intentional or unintentional, we are able to decode this information, and we can call the broadcaster and tell him you are interfering me, or call the satellite operator of that MAC address and say your customer is interfering me, and this way we solve the interference very quickly.
It's a great tool to have, the carrier ID. In fact, we've been discussing this for many years now. Having it and possibly be regulated somehow will allow us to actually to solve a lot of the interference issue, the friendly interference issue, basically. Hossein Bokhari, I'm gonna give you the chance to ask a question to David. Let me just find you on the screen first. And please present yourself. Tell us who you are. 1 second. I'll tell you when I'm ready. Okay, you can start now, Hossein.
Thanks, Tony. Really appreciate it. Hey, David. Hope you're doing well, buddy. Just wanted to ask you, you know, the product that you're using, especially with your thrusters, it has a lot of potential for deep space missions. Are you and the team thinking about how to utilize and how to position yourself for deep space missions? And if yes, where does that fit into your roadmap?
Hey, thanks, Hussein. Nice to see you here. So what we see from the deep space market is that for us, it's more of a niche market with regards to constellations. It doesn't mean that it's a small market. It means that for us, it's hard to, let's say, deep space comes with its unique technical constraints, and it's hard for us to invest heavily on this without having a certainty that let's say we have a mission that is going to use our technology for this exact, let's say, use. So intrinsically, yes, proportion, let's say we are miniaturizing the Hall effect technology that has been used on deep space missions. It has some, let's say, unique differences, particularly with regard to radiation levels, to thermal environments. But eventually, as what we do on other side of developments, we are pretty efficient in how quick we develop some hardware. So let's say starting from 2022, I believe that we could be able to address such missions, provided that there is, let's say, an identified need with a given launch date and so on. So that's where we see it's not. We are not putting a lot of internal efforts on precisely this use because it's not the market that we prioritize. But if we would let's say, put that in priority, we could be able to address that in a 2 to 3 years time frame.
And in fact, I have a question for you, David. Thank you so much for the answer. We heard about from Chuck how much it would cost these little robots to launch them to the moon. Your small products. I mean, if you can't tell us the price, but could you tell us sort of the percentage of cost with respect to a CubeSat, for example? Or would you be able to tell us pretty much what would be a cost of a single propulsion engine?
Yeah, sure. So, say what we want in orders of magnitude, the cost of propulsion is about 10% of the cost of a launch satellite. That's what we see in larger satellites. That's what we also see in small satellites. Price is a variable for many things, and it really goes with the product itself. Because let's say propulsion is so key particularly in the launch deployments, then actually different performances will lead to really different time to orbit, which then has an impact on revenues and time to market, and which in a sense the price of the propulsion system, let's say, can be a second degree variable with regards to the benefits it brings. But it's still 10%, let's say plus or minus 5% of the satellite. It's hard to tell you one price from one propulsion system because we have many different configuration, and it's heavily reliant on what is on the number of units ordered in order to amortize some non-recurring costs. But it varies essentially in between 50 to 300K depending on the various elements.
And there's nothing smaller. I mean, if I would just want to have something for a CubeSat to maneuver during the orbit transition, not so much to change the orbit from 400 to 1,000 kilometers, but assuming that the CubeSat is put into an orbit at 300 kilometers, is there a particular sized propulsion system of, I don't know, 200-300 grams, I suppose, that could be fitted on a CubeSat in order for that CubeSat to be sort of maneuvered out of any danger, for example?
Yeah, I see. So it's not, let's say, a very small propulsion needs for pure short-term station keeping or small orbit phasing is not really what we are addressing first. But when you start to remain 3, 4, 5 years in orbit, plus anomaly phasing, plus a budget for collision avoidance, plus the orbitation, actually you start to find out that you need to be in the 50, 100 meters per second of delta V range. And in that case, you start to need quite a bit of impulse. And in that case, even if it's not definitely not 200 or 300 grams, actually, it can be worth to embark a system. It's fairly small, the smaller products that we have. And it's also quite flexible in terms of how you can put it in your small spacecraft. But to give you an idea, we do not do anything below 6-unit CubeSat. And the reason is that, as I said, propulsion does have an impact not only on the mission, but also on GNC, for instance, on, let's say, power, on energy as well. And because of that, we do not think it makes much sense to embark an electric propulsion system on 3-unit CubeSat. We don't see that coming.
Okay, no, thank you for that. Also for clarifying this, Alvaro. On your side, you're offering, I suppose, a service, and are you able to tell us a little bit more about the cost for a company that would like to get your services?
Sure. So basically, our products goes from the 10,000s to the 100,000s. That's probably the cost. So, but however, all these tools enable a very rapid return on investment. So it enables the customer to save significant investment in expenses, in operational expenses. So we have return investment calculators. And compared to our competitors, we are having pretty good pricing. So we are not always the cheapest ones, so we are not always the lowest cost ones. We are the highest value for what you pay. So it is not, we cannot compete with Chinese. For us, it's very difficult. What we can compete is in quality as well as in decent prices, affordable prices. So, and very flexible. So we include new software releases, new software developments, and a lot of support and let's say a lot of experience, 30 plus years experience. So it is something that I believe that we have a good mix in that regard. We have people that have been in the company for more than 25 years. So it is a good mix of people that, and we have young engineers as well. So there is something that we like to do as well with the younger generations. We invite kids to the office a couple times a year, and we try to engage them in the engineering background and try to interact with them and make them engineers for a day, we call it. So it is we like all type of generation, and I believe that together we are strong.
Excellent, thank you. I think that I'll introduce you to a big institution sometime soon, but we need to sign up a contract between me and you so I can get some shares. Chuck, maybe one of the last questions, because then we're going to close off. Are your company thinking of any commercialization possibilities? You know, what can you do with these tiny robots on the moon, but from a commercial perspective? And you know, yeah, basically, if I am a private person, what can I do with your company to use your robots on the moon, or maybe even in Mars, for example, or Venus?
Venus, they would just melt. That's the Mars. I don't know. I don't see the business case for Mars. Sorry, Elon. And so teleoperation with multi-minute delay is a different challenge. As far as commercial on the moon, the service that we see being the near-term commercial service is the government data sale. The whole bit about prospecting and determining what the real resources are requires surface technologies that can provide what I said was assay grade ground truth. You can't raise money for a lunar resource business until you know the concentration and availability of those resources. And the way you get that is with surface exploration technologies like we're doing. What we think is a potential backspin terrestrial business that could be very interesting is that these small walking robots in challenging environments could be emergency response systems. If there's an earthquake, if there's a tsunami, if there's a mine cave-in, you need to send something in to see if there's any survivors underneath the rubble. A small 10-centimeter robot that can navigate through small holes could be a good terrestrial response unit. And there's plenty of tragedies around the world every year that sort of thing happens. And so we do see terrestrial applications for the tech once we have it proven.
Oh, thank you. I suppose you're looking also the possibility of asteroids or not comets, I suppose, because they're very harsh environment, but I suppose some asteroids possibly.
Whenever there's a ride, those are all challenging missions too, but any ride that's available, we're willing to book. We focus on what our core technology is, and if we can find a ride someplace, we're happy to go along.
Great, thank you so much. So last thing to all the panelists, I wanted to thank you to join us this week. Do you have any last minute, last thing that you want to say to the audience before we stop? Anyone? even say goodbye. Have a nice day.
Thanks, Tony. Always great.
Thank you to you, and also thanks to the audience. I appreciate. Oh yes, I appreciate very much the. I couldn't actually show my presentation. If I just you allow me just a couple of seconds to find share screen. Can you see my screen?
Not yet.
Oh, what's happening here?
Not yet, Tony.
Huh?
Not yet.
I want to share my screen. Let's see. But basically, what I wanted to do is thank the sponsors, David and Alvaro, for sponsoring the webinar. I apologize, I wasn't able to show the presentation with your logos, but basically, thank you so much for sponsoring this week's webinar. I really appreciate it. This is run on a voluntary basis by myself, and the cost will be covered by your participation in other companies who have participated also in the past. So I hope to see you again in the near future. Next week's webinar is on the insurance for satellites, space in general, basically all the space assets. I hope to see you then. Take care, stay safe, and thank you so much. Bye-bye.
Bye-bye. Thanks to everyone. Bye.
Bye, Al.
Thank you very much, Tony.